Hello, math students. Today we're going to be going over the next lesson. The next tutorial is inverse functions. We're going to be going over the tutorial, mastery test, and the practice. So have paper and pencil ready, as well as a calculator. Write down everything I write, and I guarantee you that this will make complete sense and it'll be a lot easier. Okay, so just follow along and let's go ahead and get started. So if you're on the tutorial, go ahead and move to page 5 and let's go ahead and answer this warm-up. So this is going to be a key thing when it comes to the rest of this lesson is solving equations in general. Here we're trying to solve this equation for k. What I want you to notice is that this equation has k and b in it, but we're just trying to get k by itself. Whatever we're trying to solve for, in this case, we're trying to solve for k. One thing to keep in mind is that we can go ahead and combine these k's on this side. So 3k plus 7k, they are already together on the same side of the equation. So we can go and add those together. Notice this is a negative 3k plus 7k. So that makes 4k. Okay. We also have a plus 3 here on this side, while on the other side we have 5b. Now, again, my goal is to get k by itself. So my next step, I'm going to go ahead and get rid of this plus 3. And the way we do that is by subtracting 3 on both sides of the equation. This will give us that 4k equals 5b minus 3. Hopefully you see the last step is to divide by 4 on both sides to get k by itself. Again, hopefully you're writing all this down so that you'll understand it to the fullest extent. So we got 5b minus 3 over 4. So when we write it here, make sure to do the 5b minus 3 on top. And then click down here. What was it, over 4? Yeah, over 4. Okay, and that'll be it. Okay, let's go ahead and move along. You could skip ahead till when it stops you. It'll stop you when you get to the next series of questions here. Now, this one, we're going to learn how to, this will be a key part of this lesson, and many questions on the mastery test kind of revolve around this concept of here we give you a function, and basically we want to find the inverse of this function. So what is an inverse of a function? So one thing to kind of know about an inverse is that whatever point on the inverse, whatever point on the original function, let's say, so this is, let's say, a point from the f of x. So it's a point on the original function. An inverse is a reflection across this line. And this line is the line y equals x. So if you have a point on your original function, then if you reflect across this line, y equals x, you'll actually get a point on the inverse function. So f inverse of x. And we write it like this. So if your original function is f of x, then we write this as f inverse of x. Notice I write f, and then there's like an exponent here to the power of -1 of x. So that indicates that these two functions are inverses of each other. And any point on this, the reflected point will be, you'll see. So if this is the point x equals x comma y, then this will be y comma x. So basically the whatever coordinates you have from your original function, the coordinates of the inverse function will be just flipped. So if this is like 5 comma -1, then this will be like -1 comma 5. Okay, I clearly did not graph it in the right spot, but you get the idea. Okay, now how do we take a function like this and find its inverse? Generally, the process looks like this. The first thing we do is replace f of x with y. So go ahead and write this down. Then we switch x and y. So the next step will be to switch x and y. So what would that look like? Well, instead of y, we're going to put x. And instead of x, we're going to put y. Now from here, this is the main kind of before the work really, is just replacing f of x with y, then switching your x and y. Then from here, what we're going to do is simply solve for y. So our goal now is to solve for y. Well, what would I do first to solve for y? One thing we can go ahead and do is we can go ahead and subtract 9 on both sides of the equation. Again, I'm trying to solve for y. Also, I'm going to put this negative 3/4 y. I'm actually going to put it on the left side of the equation. And over here, we'll have an x minus 9. You can't combine these terms because they're not like terms. Then perhaps I would multiply by 4 to cancel this out, multiplying this side by 4 as well. So that gives me negative 3y equals 4x minus 36. This 4 multiplies with both the terms here. Lastly, to get y by itself, we divide by negative 3. And both of these get divided by negative 3 as well, giving us that y equals, we'll call this negative 4/3 x. And then a negative divided by negative, well, that's a positive. So that's going to be plus 12. Now, our very last step is you simply replace y with f of x. Or sorry, since we're finding the inverse, f inverse of x equals negative 4/3 x plus 12. Okay, so that's basically how you do it. The main thing to start off with, replace f of x with y, then switch where your x and y are, solve for y, and then replace y with f inverse of x. So let's go ahead and put these steps here. So if I want to find the inverse of this, first thing I'm going to do is replace f of x with y. Then I'm going to switch where my x and y are. Next, I'm going to start solving for y. So my first step will be to subtract 9 on both sides. Then they multiplied by the opposite reciprocal. They multiplied by negative 4/3. So which one shows that? I guess this one. Okay. Then they distribute this negative 4/3. Also, they did what I did, where you put the y on the left side. Then they replace y with f inverse of x. Let's make sure we're correct. Nice. Okay. Now, here we have some coordinate points. They give us some coordinate points for our original function, f of x. Notice these coordinate points are negative 1, 1, 0, 2, and so on. Now, what points would be on the inverse? So, f inverse of x. So the coordinate points are going to be these flipped. Remember, your x becomes your y becomes your x. So in this case, instead of negative 1, 1, we're going to put 1, negative 1. Instead of 0, 2, we're going to put 2, 0. Instead of 1, 3, we're going to do 3, 1. Instead of 2, 4, we're going to do 4, 2. Then we're going to graph these points. So 1, negative 1, 2, 0, 3, 1, and 4, 2. So let's go ahead and graph these on our chart here. So we're going to go ahead and use the point tool. And let's do 1, negative 1, 2, 0, 3, 1, and 4, 2. Notice our points all line up, which is good. Okay. Now this one's very similar to the last one, actually. Here we have some function here, and we would like to graph its inverse. So what we can do is we can find the x and y coordinates of these 2 points. So what are these coordinate what are the coordinate points for this point, and what's the x and y coordinate for this point? So for this point, this is -6, 6. For this point, it's -2, -5. Okay, so for our inverse function, we're going to have, instead of -6, 6, we're going to have the coordinate point 6, -6. Again, flipping the x and y. We're also going to have the point -5, -2. Let's go ahead and graph those points. So 6, -6 down here. And then -5, -2. -5, -2. Okay, then you would connect those with a line segment. And there you go. This new line here that I just drew, this is the inverse function of our original. Notice it's a reflection across the line y = x. An inverse function is always a reflection across y = x. And you can see that here. Okay, so we would just use the point tool. So -2, -5, it's going to be -5, -2. And then -6, 6, 6, -6. Connect these with the line segment, and there you go. Looks good. All right. Well, that's the tutorial. Pretty quick. Now let's go ahead and do the practice. So go ahead and click on the practice, and we'll work through these problems one at a time. So this type of question here, is the very first type, is probably the hardest type. The first thing you want to do, actually, nah, I don't think they're very hard at all, actually. I changed my mind. The first thing we want to do is just find a couple coordinate points for this function. So you could use any x and y coordinate points, but I want to pick coordinate points that are actually going to be on this graph. All right. If it's off the chart, then maybe I should pick smaller numbers. But in general, I could pick any x and y coordinates. So for this graph, I'm going to go ahead and choose maybe 0 for x. And then I'm going to choose maybe 1. And you could choose any points you like, but I'm just going to choose these small points. And again, if it ends up being off the chart, then I'll pick different points. Okay, so how do I find the corresponding y coordinates? Well, I'm going to replace x with 0 to figure out my y. So in other words, I'm going to find f of 0 for this input of 0. So what does this equal? 2 times 0 is 0. 0 minus 4 is -4. Great. So 0, -4 is a point on this function. Let's go ahead and find another point. Find the other point. So here I'm going to replace the x with 1. So I'm going to find f of 1. So this is going to be 2 times 1, again, replacing the x with this x coordinate, minus 4. This becomes 2 minus 4, which is -2. So this function will have these coordinate points, 0, -4, as well as 1, -2. So this is for f of x, which means that the inverse function, f inverse of x, will have these flipped. So instead of 0, -4, it's going to be -4, 0. And instead of 1, -2, it's going to be -2, 1. So what you would do is we're going to go ahead and create a line that goes through those 2 points. So you can go to -4, 0. That's right here. And then -2, 1, which is right here. So our inverse line, you could just make a line that goes through these 2 points and it'll form the rest of the line for you. If you're using the line tool. So you want to use the line tool, click here, then drag to here, and it should create the whole line for you. Make sure your line looks exactly like my line here. So that's kind of it. If you have coordinate points, you just swap the X and Y and then graph those new coordinate points. So for example, here, this one's even easier because they give us, we just need to see what the coordinate points are. So this first one is -1, 4, X and Y. And this point is -6, -2. So our inverse function, we're going to have the points 4, -1, again, flipping the X and Y, as well as the point -2, -6. Let's go ahead and graph these points and to draw our inverse function. So you can use the point tool on your practice here, but -4, 4, -1, and then -2, -6, -2, -6. Go ahead and connect these using the line segment tool, and you should have that as your inverse function. Question 3, if the X and Y values in each ordered pair of a function are interchanged, so changing X for Y and Y for X, what is the resulting set of the ordered pairs known as? That's your inverse function. That's what we're talking about. Great. Okay. Consider this function, X and f of X. Which of these tables would represent the inverse of function f? So for the inverse function, once again, wow, that's too big. For the inverse function, you just flip your X and Y coordinates. So here, -1, -21 becomes -21, -1. 0, -9 becomes -9, 0. 1, 3 becomes 3, 1. And 2, 15 becomes 15, 2. So the inverse function will contain these coordinate points. So that's this one. Yep, easy. Okay, here we have a function and we want to find its inverse, the graph of its inverse. Well, let's see. Let's find a couple of points for this function here. So one point for this function, and we can go ahead and use any X coordinate we want, but I like to use 0 because that usually works out pretty easily, because essentially 1/2 times 0, well, that anything times 0 is 0, plus 1/4 is 1/4. Okay, so this function, f of X, will go through 0, 1/4. Now, I know I don't like dealing with fractions for the most part, if I can avoid it, but in this case, they kind of forced our hand a little bit. Now, let's go ahead and find another coordinate point. I'm actually going to use 2, and you'll see why. Because what's 1/2? And I'm going to replace the X with 2 plus 1/4. Well, this 1/2 times 2 is 1. 1 plus 1/4 is 1 1/4. Okay, so that means our inverse function, so this is for f of X. What about for our inverse function? F inverse of X. Well, the X and Y coordinates are going to be flipped. So we'll have 1/4, 0, as well as 1 1/4, comma 2. So we can just pick the graph that has these points basically. So 1/4, comma 0. Well, this one looks like it has 1/4, comma 0. And that's the only one. Okay, so it must be this one, graph W. Let's double check our other point. 1 and 1/4, comma 2. 1 and a little bit, comma 2. Yeah, that seems right. So we know that that's the correct inverse function. Which of the following is the inverse of this function? Okay, well, remember, in order to find the inverse function, this is kind of the long process one. The first thing we would do is replace f of x with y. Then switch our x and y. Now our goal is to solve for y. So my next step here would be to subtract 5, both sides of the equation. And I'm going to move this 4/3 y to the left side. Here we have x minus 5 on the right. We can multiply by 3 on both sides to cancel out the fraction. Remember, whatever you do to one side of the equation, you have to do on the other. This will give us 4y equals, and we're going to distribute this 3. So the 3 multiplies with both these terms here, giving us 3x minus 15. Lastly, divide both sides by 4 to get y by itself. Then replace the y with f inverse of x. So f inverse of x equals 3x minus 15 over 4. This one's the same deal. We just got to find the inverse function. So we have y equals negative 5x minus 9. Replace our x and y with each other. And we're going to solve for y. What do you think our first step here is? Well, we're going to add 9 both sides of the equation. And I like to move my y's on the left side here at this step. Divide both sides by negative 5. Giving us that y equals x plus 9 over negative 5. And again, we should replace the y with f inverse of x, right? This one's the same idea. We're going to go ahead and replace f of x with y. So this is y equals 4 minus 9x. Swap the x and y with each other. So x equals 4 minus 9y. And now our goal is simply to solve for y. So for our next step, we're going to subtract 4, both sides of the equation. I'm going to move our y's to the left side at this step. So we have negative 9y. This negative sticks around here on the 9y because this negative more or less belongs to the 9y or is applied to the 9y. So it sticks around. These 4's cancel, but over here we have x minus 4. What do you suppose our next step would be? Well, we're going to divide by negative 9 both sides to help us get y by itself. What's my last step here? Well, we're going to replace y with f inverse of x. Okay. Here they split this into 2 fractions, it looks like. So that would be negative 1/9 x. And then negative over negative makes that positive 4/9. Okay, here we're going to move these. Let's go ahead and solve this on the side, and then we can move the steps easily once we have it solved. So we're going to have f inverse of x. I'm actually going to go ahead and replace that with y. Our first step will be y equals 2x plus 5. Then we swap the position of the x and the y. My goal now is to solve for y. So here I'm going to go ahead and subtract 5 both sides of the equation. And I'm going to move my y's to our left side here. And the x minus 5 on the right. Lastly, to get y by itself, we're going to go ahead and divide by 2, both sides of the equation. And we have x minus 5 over 2. Lastly, replace y with f inverse of x equals x minus 5 over 2. So let's go ahead and put these in the correct steps. So my first step will be to replace f of x with y. So this will be my first step. Then replace, swap the position of x and y. So this will be my next step. Then we subtracted 5 both sides. So we'll have x minus 5 equals 2y. Then we divided by 2 on both sides of the equation to get y by itself. Lastly, we replace y with f inverse of x. And they moved the y to the left side. Let's make sure all those are all the steps. 1, 2, 3, 4, 5. Great. For this one, they give us 4 linear models here, and we want to find the inverse of each of them. So for each of these, we're essentially going to find the inverse. So we're going to swap the x and y, and then we're going to solve for y. So let's go ahead and start with this first one. So this is going to be 4x plus 3y equals 6. Swap the x and y. That's always our first step. So that's going to be 4y plus 3x equals 6. To help us get y by itself, we're going to go ahead and subtract 3x both sides of the equation, giving us that 4y equals negative 3x plus 6. I like to put my x's in front of my constants. Lastly, divide both sides by 4. I don't like that color. Divide both sides by 4 to get y by itself. Divide this by 4, divide this by 4. So it'll be y equals negative 3/4 x plus 6 over 4. 6 over 4 can be reduced to 3 over 2. So this is going to be our first one here. This one goes right there. Let's go ahead and try the next one. Once again, swap the positions of x and y. Swap the positions of x and y. So this will be 3y minus 4x equals 6. And our goal, once again, is to get y by itself. So we're going to start by adding 4x to both sides of the equation, allowing me to cancel right here. This leaves us with 3y equals 4x plus 6. Lastly, to get y by itself, we're going to go ahead and divide by 3. Remember, these are multiplied, so we cancel it with division. divide each term by 3, giving us that y equals 4/3 x. 6 divided by 3 is 2, so plus 2. 4/3 x plus 2. So this one goes here. All right, 2 more. All right, next one. We're going to swap the x and y right away. So 4y minus 3x equals -6. We're going to add 3x to both sides of the equation, canceling it here on the left. This gives us 4y equals 3x minus 6. Then divide by 4 to get y by itself. This 6/4 reduces down to 3/2. 3/4 x minus 3/2. Last one. Replace x with y and y with x, and solve for y. I hope you see the next step would be to subtract 4x on both sides of the equation, giving us that 3y equals -4x minus 6. To get y by itself, we're going to go ahead and divide by 3 on both sides of the equation, giving us that y is -4/3 x minus 2. -4/3 x minus 2. Oh, those are all different colors here with the arrows. I didn't even do that on purpose. Just a happy accident. Which function represents the inverse of function f below? All right, so now we're on the mastery test. I have 20 questions here. You're going to be given a sample of 5 of these questions. So I will go over your questions at least a little bit. I will give you a hint on each question. And hopefully, if you've been following along, you should be able to do it on your own with minimal help. Okay, so let's go ahead and figure out which of these is the inverse. So remember, the first thing I would do is I'm going to replace this with y equals 3x plus 5. Then swap my x and y. So this would be x equals 3y plus 5. Then what you want to do is simply solve for y. Figure out which of those would be the result. Find the inverse of function f. So this is more the same. I'm just going to go ahead and do the swapping and everything right away. So x equals 1/2 y plus 7. And go ahead and solve for y. This one's a little bit trickier, so we're going to go ahead and subtract 7 on both sides of the equation. And I'm going to move my y to the left side. X minus 7 here. Then to get rid of the 1/2, we're going to multiply by the denominator. So multiply by 2. Multiply this side also by 2. This cancels here, leaving us with y. Then distribute this 2 here to find the inverse function. Keith used the following steps to find the inverse of f, but he thinks he made an error. Let's see. He's switched f of x with y. That looks good. Then he changed out y for x and x for y. Switch x and y. That looks good. Now, here he had x plus 7y plus x equals 7y plus 5. Now, what would I do next here to solve for y? What would I do next to solve for y? Okay, think about it. Consider this function. Well, let's find a couple of coordinate points for this function f of x. So one thing I could go ahead and check is maybe I'll check 0 and 1. So I like to use 0 and 1, or it doesn't really matter what numbers you pick as long as you don't go off the charts. These charts go up to 5, so this will work. And again, it doesn't matter what x coordinates you pick, just don't go off the chart. Okay, so if I replace x with 0, this would be 0 plus 4. Well, 0 plus 4 is 4. If I replace x with 1, this would be 1 plus 4. So f of 1 is 1 plus 4, which is 5. So the original function, f of x, will go through these coordinate points, 0, 4, and 1, 5. Therefore, the inverse function, you would simply swap those x and y coordinates. So instead of 0, 4, it'll go through 4, 0. Instead of 1, 5, it'll go through 5, 1. So 4, 0 and 5, 1. 4, 0 and 5, 1. So which of these graphs has those coordinate points? Here we want to find the inverse. Once again, I'm going to replace f of x. I'm just going to go and skip a step and just replace it with x. Then I'm going to replace the x with y. Replace the x here with y. And my goal here is to solve for y. What would be my first step here? Well, no, I notice this 3 minus y is over 7. So what I can do is just go ahead and multiply by this denominator here, canceling it out, which means I also multiply this side by 7 as well. 7x equals 3 minus y. Okay, see if you can finish solving for y to find the inverse. Actually, for that one, since it's a negative y, I'll go ahead and continue finishing this up for you. So let's go ahead and subtract 3, both sides of the equation. Here we have a negative y equals 7x minus 3. Now notice this is a negative y. So how do we get rid of that negative? Well, one thing, you could think of it as a negative 1 in front here. So we can divide by negative 1 to cancel it out, which means you have to divide these terms over here by negative 1 as well, giving us that y equals negative 7x plus 3. Replace y with f inverse, and you're done. All right, so for this one, they give you some coordinate points. These points define a function. Now, if this is a coordinate point on f of x, so one coordinate point they have is that negative 49, 7. Right, this is the x and this is the y. Then what would be a coordinate point on the inverse? Well, for the inverse then, it would have 7, negative 49. That's supposed to be a 4 there. That's better. So if this is from the original function, then for the inverse function, we'll have this point, 7, negative 49. And then swap the rest of these and figure out which of these lists correctly shows that. Okay. This is, we're going to find a couple coordinate points for our original function, f of x. So for f of x, what are some coordinate points for this function? Well, once again, I'm going to use 0. And maybe I'll use, 1 works here as well. So when I replace x with 0, this will be -3 times 0. Well, that's 0. 0 plus 3 is 3. And again, you could choose different coordinate points. It doesn't matter. Just make sure your coordinate points stay on the charts that are given. Then when I replace x with 1, what would be the result? Well, this would be -3 times 1 plus 3. Well, -3 times 1 is -3. -3 plus 3 is 0. So if these are coordinates for the function, what would be coordinates for the inverse function? Okay, so find the coordinates for the inverse function and make sure you pick the graph that has those coordinate points. Here we want to find the inverse of this function here. Okay, so I'm going to go ahead and just swap f of x with x and replace x with y. We did one very similar to this earlier. We would multiply by 5 both sides of the equation. And I'll go ahead and move this 3 minus y to the left side here. Okay. Go ahead and finish solving for y and make sure that you're solving for y, not just negative y. All right. If these are points on our function, which of these represents points for the inverse? So remember, for the inverse function, you would swap the x and y. So instead of -1, -2, it would be -2, -1. Swap the rest of the points to find the correct inverse function. Here we have our function. We want to find the inverse. Okay, pretty straightforward. Here, replace f of x with x. Here it has 10/9, and I'm going to replace x with y. Now, again, my goal here is to get y by itself. So my first step perhaps will be to multiply by 9. I can multiply by 9 first, and that's fine. That way it cancels my fraction right away. So I get 9x over here equals, and this will be 10y, canceling the 9 with that 9. But this 9 also multiplies this 11 here, so plus 99. I'm going to go ahead and subtract 99 both sides of the equation. Remember, whatever you do on one side, you have to do on the other. So we're going to have 10y. Again, I'm moving my y's to the left. Equals 9x minus 99. Okay, finish solving that and figure out which is the inverse. Okay, well, more fractions. I replace f of x with x, and I replace x with y. For this one, my first step I'm going to do is I'm going to subtract 1/3 both sides. And I'm going to move my y's over to the left side here. X minus 1/3, just like that. Now what we want to do is we want to multiply both sides by -21. That way the negative times negative comes positive, and the 21 cancels with this 21. So here, and the reason that kind of works because this is 1 divided by 21, and this is multiplied by 21. So the multiplying and dividing by 21 cancel each other. And we also have to multiply this side by the same thing, -21. it gets distributed to both these terms here, giving us negative 21x plus, how do we multiply a whole number times a fraction? Remember, you multiply times the top, then divide by the bottom. A negative times negative makes positive. 21 times 1 is 21. Divided by 3 is 7. Okay? So which of those is equivalent to this? All right, let's see where someone made a mistake. Let's see. They replace f of x with y. Then they replace y with x and x with y. So that looks good so far. Oh, looks like you should have added 2 to both sides of the equation, right? Okay. If the point -8, 3 is a solution for f, then the point blank blank is a solution for the inverse of f. So what do we do with these points again? Okay. Here we want to find the inverse function of f of x equals 2x minus 4. So I'm just going to write it, y equals, and I'm going to replace the x with y here. Let's go ahead and add 4 to both sides of the equation. And I'm going to go ahead and put my y's on the left side. I prefer my y's on the left side. Here we can't really combine these because it's a variable plus a constant. You can't really combine those. Lastly, to get y by itself, we're going to go ahead and divide by 2, divide by 2, divide by 2. So giving us that y equals, we'll call this 1/2 x plus 2. So you could put 1/2 in here and a plus 2. Okay, so for this one's pretty straightforward. Don't forget, for the inverse function, you flip the positions of the x and y for each coordinate point. Okay, for this one, we're going to go ahead and find a couple of coordinate points on the function f of x. And then that'll allow us to find points on the inverse. So for example, here's a point here. This is the point, looks like 0, 1. And then we could use, I like to find points that are directly on the grid lines. So this looks like this is on the grid lines here, right? 5, 2. Okay, so if 0, 1 is a point on the function, then for the inverse function, you would swap that position. Swap the x and y. So instead of 0, 1, it would be 1, 0. Instead of 5, 2, it will be 2, 5. So you'd want to graph those points and make a line connecting them. Okay, this one's the same deal as the last one. Here we could use this coordinate point for a point that's on the original function, 0, 4, or sorry, -4, 0. And then we could use this point as well, 0, -8. So remember, the inverse, for the inverse function, you would swap the positions of the x and y. So instead of -4, 0, it'll be 0, -4. And instead of 0, -8, it'll be -8, 0. Graph those points and make a line connecting them. Here they give us some coordinate points, but we want to graph the inverse of this. So instead of the point -4, 9, we'll have the point 9, -4. So I'd use the point tool, graph that point 9, -4. And then do the same with these other points as well. swapping the X and Y coordinates and graphing the points. This is a long one. Okay. So here we have our function f of x. Our first step will be to swap out f of x for y. Our next step will be to swap x and y. So x equals 4y plus 7. Then I'm thinking we should subtract 7 both sides of the equation. Giving us x minus 7 equals 4y. Then we divide both sides by 4. And we'll move the y to the left side here after these 4's cancel. X minus 7, 4. Then lastly, replace y with f inverse of x. So make sure to put the correct steps in this order. What is the inverse of the function below? So here we have a couple of coordinate points. We would just swap the x and y. So for this coordinate point, this is 8, 3. So swap that x and y and graph that point. And then this is -2, -7. Swap the x and y here and graph that point as well. Connect those points using the line segment tool. Okay, well, that's it. Hope you found it helpful. And if you did find it helpful, make sure to share this with someone else who you think would also be helpful for. And like, comment, subscribe, for the algorithm. Well, anyway, thanks for watching, and I'll see you guys next time. Take care.